Okay, so
No.
at velocity is the rate of change of displacement with an object with respect to time. So if s is the displacement, then v is equal to ds by dt, and acceleration is the rate of change of velocity with respect to time, or excuse me, dv by dt, or d2s by dt squared, right, or the second derivative of the position function. So in other words, if s is the displacement, then ds by dt is velocity, and d2s by dt squared is the acceleration. The graph to the right shows the velocity of an object. What can you say about the acceleration in the interval from a to b? So what's the acceleration? What's the slope of that one? Constant and positive, right? So it's like constant and positive. So from a to b, the acceleration will be constant and positive. From b to c, the acceleration is 0. What's that doing to the velocity then? Yeah, the velocity will remain constant, right? Whatever it was. From C to D, increasing, so let's say positive and increasing, right? So positive and increasing. And from D to E, positive, but it's decreasing, right? So now it's concave down. So it's still positive, but it's decreasing. And E to F, now don't think of decreasing as going down and increasing as going up. Think of increasing as so this is increasing, right? Because the slope is getting steeper. Okay, so it's negative, right? That's its direction, but it's increasing because it is getting steeper. So don't let the direction of the slope interfere with the magnitude of the slope. All right, so that's reading a velocity graph, right? And just in terms of that, interpreting it as acceleration. The height of an object is given by h of t is negative 4.9, blah, 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 where t over there. Determine the acceleration of the object. Okay, so what do we have to do first? Just one of each. One of each color. There you go. Okay, so first we do so we find the velocity, right? So we can say v of t is equal to h prime of t is equal to negative 9.8 t plus 20. And then we could say, well, the acceleration, so a of t, is equal to v prime of t is equal to h double prime of t, which is what? Negative 9.8. And it's going to be negative 9.8 meters per second. So I mean, this thing here is in meters per second, and this is meters per second, right? Or meters per second squared. Okay, which is the units for acceleration, meters per second squared. All the bubbles like this. Well, there's no alcohol in it, therefore. It's a Meyer lemon and San Pellegrino sparkling water. It's got high sulfate content. That's good for you. The displacement function of an object is given by s of t is 1/4 t to the fourth minus 3t, etc., etc. Determine the velocity of the object when its acceleration is 0. So what are we going to do first? We'll find the first derivative, which is going to give us the velocity Then we need to know when the acceleration is 0, so we're going to have to find the second derivative to get the acceleration and then set that equal to 0 and then go back to the velocity and say how fast is it going when that acceleration was 0. Okay, so first V. Velocity is the first derivative, right, or the derivative of the position function. So what do we get? 4 times a quarter is 1. T cubed. Okay, so that's our velocity, right? What do we have to find? The velocity when the acceleration is 0. How do we find when the acceleration is 0? Well, we need to get the acceleration, right? So A of t, which is v prime of t, which is s double prime of t, which is 3t squared minus 18t plus 24. And now the idea is, okay, so I need that to be 0, right? So all we're going to do is set that equal to 0, right? Say when its acceleration is 0. Okay, so 3t squared minus 18t plus 24 is 0. Let's factor that. 3 minus 6t plus 8, 0. And what do we get? T minus 4 and t minus 2. So A is 0 when t is 4 or t is 2, right? And what we were asked to find is what's the velocity when the acceleration is 0? Right. So we need to go work out, well, what's v of 2? Okay, and we've got v of t. So it's 2 cubed minus 9 times 2 squared plus 24 times 2 plus 7. 8, what do we got? Minus 36 plus 48 plus 7. So what's that give us? 27 or something? Okay, we could toss some units in, right? It's 27 meters per second. And v of 4. 4 cubed minus 9 times 4 squared. That's 24 times 4. 4 cubed, what? 64? 9 times 16, 90 and 50, 144. 80 and 16, so plus 96, plus 7. So what do we got? Like 23 or something? 23? Yeah, 23. Okay, and we have done what we were asked, right? Determine the velocity of the object when its acceleration is 0. So the first time its acceleration is 0, it's going 27 meters per second, and the second time then it's going 23. Determine when the acceleration is positive. Okay, so acceleration is this, right? So when is that positive, right? So we can just do a little sign analysis, right? We've got zeros at 2 and 4, so if you've got a 0 at 2, then on one side of 2 it's positive and one side it's negative. Okay? So just do the whole thing with 2 and 4. And I assume we're not really going below 0, right? It doesn't make any sense to do negative times. Okay, and we've got 3 factors, and t minus 4, and t minus 2, and this is a of t. Right? So we're not doing intervals of increase and decrease here, right? We're just looking at when is the acceleration positive. Okay, so 3, well, that's going to always be positive. T minus 4 and t minus 2 Okay, so the acceleration is positive then in the interval from 0 seconds to 2 seconds, and then from 4 seconds onwards. So acceleration is positive. Zero to 2, and 4 to infinity. That kind of makes sense, because, you know, at 2 seconds it was going 27 meters per second, and at 4 seconds it was going slower, so it had to slow down, right? So its acceleration had to be negative between 2 and 4 seconds, right? In this interval, there had to be something negative going on to slow it down. The position of an object is given by S of t is 2t cubed minus 12t squared plus 18t, rest is meters of t in seconds. So that's a t-axis, so this will be the s-axis. Draw a graph of the position function for t goes from 0 to 4. So I guess really all we need to do is just sort of, well, let's take a look at that and see what's happening. Is that factorable? So we can do, so s of t is going to be, so we take out a 2t, right? And what does that give us? T squared minus 6 plus 9. That's t minus 3 squared. So we have a 0 at 0, and we have a 0 at 3 of multiplicity 2. So we get a 0 here, 0 here. So it's a positive cubic, so it's going to kind of like go up and then come down and kind of bounce off of the 3 and head back up again. And so, well, we could throw some numbers in, right? So at 1 second, what do we got? 2 to minus 2, minus 12, 8, right? Yeah, 8. Okay, so 1 second, it's 8. And at 2 seconds, we got 16, minus 48, negative 32, plus 36. Is that like 4? And we just want it from 0 to 4, so at 4 seconds, what do we got? 128. 12 times 16. That's 12 times 16. 192, maybe?
It's faster if you look at the factored form and just.
Oh, you're right. Put a 4 in there. Yeah, 4. So, what is it, 8? There are certain efficiencies, which I guess if we have the brains we can use. Okay, so draw a graph. So here's a graph. There we go. Determine the velocity function and sketch its graph on the same grid. Okay, so what's the velocity function? So v of t is s prime of t. Okay, I'm just doing that to communicate, right? The velocity is the first derivative of the position function. So, you know, v of t is s prime of t, which is minus 24t plus 18. So that factors, right? Both minuses. Okay, so let's use a different color then for velocity. Use red. So at time 0, what do we get? 18? This is the easy place to put 0. 18. And at time 1, well, we put a 1 in there, so we're going to get a 0 at 1. And we got a 0 at 3. And 2. So 2 minus 1 is 1, 2 minus 3 is negative 6 at 2. And then by symmetry, that'll be an 18. Okay. Well, they just wanted 0 to 4, right? use the velocity function to determine the local relative max and relative min points on the position function and adjust your graph if necessary. Okay, so do we have the right position function? Okay, so where are there local maxes and mins? So, yeah, where the velocity is 0, so that's going to be at 1 and 3. Okay, so then what do we want to do? Well, we want to work out the position at 1 and 3. So we have a local max slash min. So the local. All right, well, which is which? I mean, I guess we could just do this from here, right? So here we're going from positive to negative. So positive to negative. So we have a local going from a positive slope to a negative slope gives us a local maximum at 1. And here we're going from negative to positive, so we have a local minimum at 3. So local maximum at x equals 1. So what's s of 1? What is s of 1? What's s of t? 2t cubed minus 12t squared, 2t cubed minus 12t squared plus...
A lot of these points, why not just take them off the graph?
Oh. But, well, is that true? I mean, just because the derivative is something doesn't mean that point is there, right? There could be a shift.
Well, I plotted the original graph.
Oh, yeah, you're right. Probably the original graph. All right, so it's 8. All right, you're right. So 1, 8. And a local minimum at... which was 3, 0, right? Yes, you're right. Okay, so we got a maximum at 8, minimum at 3. Determine the acceleration function and sketch its graph. Okay, so acceleration, so we've got what, 6t squared? So it's going to be what, 12t minus 24? So a of t is v prime of t is s double prime of t is 12t minus 24. Okay, so let's do that in green, I guess. So minus 24 and a slope of 12. Wait. Sorry, up 12. And there. And there's acceleration. Determine when the acceleration is equal to 0. So when is it's at 2. The line is kind of not the best line. So acceleration is 0. So you can do it 2 ways, right? You go 12t minus 24 is equal to 0. 12t is 24, and t equals 2. At this time, what occurs on the graph of the velocity function and the graph of the position function? So at time 2, when the acceleration is 0, what do we have on the velocity function? A local minimum, right? So we have a minimum. It's going to be a max or a min. In this case, it's a minimum. So we have a minimum velocity. And what's happening on the position function? Point of inflection. Okay, so velocity function, we have a local minimum, and the position function, a point of inflection. Okay, that's it, eh? That it?